Okay, so in this video, we're going to talk about osmosis, which is the diffusion of water across or through a semi-permeable membrane. So one important thing to realize about cells is that all cells on Earth are surrounded in water. So the environment around a cell contains water, but the inside of the cell is also water. So the cytoplasm inside is almost all water. Yeah, there's organelles and ions and proteins and things on the inside, but water is a big part of what a cell interacts with on a daily basis. And it's important to remember that molecules within a cell and around a cell are constantly in motion. So these water molecules on the inside and on the outside will be randomly moving and colliding and bumping into each other at all times. So let's go ahead though and see. So here I have a cell. Now, if I take away some of the water molecules on the outside, what we see here when we talk about water in cells is the concentration of water on the inside of a cell is not always equal to the concentration of water on the outside of the cell. And if you remember diffusion is the movement of molecules from a high concentration to a low concentration. So here in this image, we have a high concentration of water molecules within the cell and a low concentration out. So when we talk about osmosis, this is the diffusion of water. So no matter the scenario, you're always going to think, okay, where is there a high concentration of water and where is there a low concentration of water? Because the water is going to move from high concentration to low concentration. Sometimes that'll be from inside the cell and it will diffuse out of the cell. Sometimes it could go the other direction. Maybe it's a high concentration outside and it's going to diffuse inside. But right now you might be thinking, well, if it's a low concentration of water on the outside of the cell, what else is there, right? So maybe in this example, maybe the cell has been placed in salt water. So right here, you could add a whole bunch of ions in the environment. These like salts into the environment would cause a lower concentration of water, but then there's more solutes is what we call it. So here, when I look at the salt here, basically, when we're talking about osmosis, anything that is not water, we call a solute. So in this example here, the environment or the solution, the liquid that is around the cell has a high solute concentration. There's a lot of solutes on the outside, but a low concentration of water. So here in this example, high solute concentration, low water concentration in the area outside of the cell, but on inside of the cell, I don't see any salts pictured. So inside the cell would have a high water concentration and a low solute concentration. Now, I use salt because it's easy to think about putting a cell into salt water. However, solutes can be other things like sugar, for example. So maybe sucrose or glucose. You put a cell into a sucrose solution to see what happens, right? So again, we would call that sugar a solute. So anything that is not considered water, we're going to reference as solutes. And so let's go ahead and look at some examples of how osmosis works, though. So here we have a cell, and if you look at this picture, you can kind of see that the concentration of water, the amount of water on each side of this membrane looks to be roughly equal. And the water molecules aren't frozen in place like you see here. Water can pass through that membrane, both in and out of the cell. But when the concentration of water is equal on both sides of the membrane, the molecules will move in and out of that cell at equal rates. So again, the molecules are kind of just moving in and out of the cell, and we call this kind of like it's in equilibrium, like it's equal moving in and out. But we have special names to describe the solution around a cell. And in this example, because the water concentrations are equal on both sides, and therefore the solute concentration is also equal on both sides, we say the solution is isotonic. So this cell has been placed in an isotonic solution where the amount of water is equal on the outside and the inside of the cell. So the water will move equally both in and out. So that is an isotonic solution. But sometimes maybe you have a high concentration of water on the inside and a lower concentration of water on the outside of a cell. So in this example here, I want you to think for a minute. Okay. There's a high concentration of water inside and a low outside, and diffusion is water moving from a high concentration to a low concentration. So here we have our high concentration of water on the inside and a low concentration of water on the outside. So with this, okay, so that's a little reminder for you. So when we look at this, as the water moves, you're going to have a majority, like more water is going to be leaving the cell than is entering. So if you look back, pay attention to the little water molecule right here. So as water molecules are colliding with each other, there's more on the inside that will diffuse out. It doesn't mean that water is stopped from entering. Water can also enter the cell, but it just so happens there's so much on the inside that the net movement, the majority are going to be moving out of the cell and not in. Now, if you think about, well, what happened to the cell? Like it turned ugly, right? So when we think about water leaving a cell, going from a high concentration to a low concentration, the cell is losing mass. So the cell will actually shrink and shrivel because water has moved out of it by diffusion. So for those of you who like words, let's go ahead and read what has happened. So when the water concentration is high on the inside of the cell and low on the outside, then water will diffuse out and the cell will lose mass, or it'll shrink or shrivel. So this type of solution, so when we think about, well, how do you describe the liquid that the cell was placed in? So when there is, oh, my face is in the way. When the cell is placed in a high solute concentration on the outside of the cell, we say that solution is hypertonic. In a hypertonic solution, there are a high amount of solutes, which means there's less water. So the water will move from where there's more water to where there's less. So in a hypertonic solution, you can expect a cell to like shrink or to shrivel. Okay, so now let's go ahead and look at it like another visual of this. So this, the salt around this cell, these cells right here, these blood cells, represent a hypertonic solution, a high amount of solutes and a low amount of water compared to the cell. So right now your job is to think, okay, where is the water going to flow by osmosis? Water is going to flow from a high concentration of water to a low concentration of water. So in this image, there are more water molecules on the inside of the cell compared to the environment. So water is actually going to flow out of these cells and the cells are going to shrivel because they're losing water to the environment. This is one reason why it's important to always stay hydrated in our bodies. If we actually like drink salt water from the ocean, let's say you're lost at sea and you drink salt water or something, then this could happen to your cells. They will actually lose water and they will start to shrivel. Okay, so now let's go ahead and look at the opposite. Well, what happens if on the outside of the cell, you have a high concentration of water? So if I look here at this cell, I see lots of water on the outside and very little water on the inside. And you might be thinking, well, when would this ever happen? Well, this could be like if you take like a saltwater fish, for example, and you put it into like a freshwater lake or something. So you're changing the ions in the environment. So here, this cell is placed in or like sometimes too, there's like little single-celled like amoebas or parameciums. And if they live in a freshwater lake, they have more solutes on their inside because all their organelles compared to the lake. So they're always living in an area that has a high concentration of water on the outside. So now you think, okay, water is going to flow from a high concentration to a low concentration. So the water molecules here are going to diffuse, so from high concentration to low concentration. And they're going to diffuse it all. So while they can move in both directions, you're going to have an overall net movement of water into the cell. So pay attention. I'll play it one more time. All the water molecules are moving around, but when you have them randomly moving, if there's so much on the outside, you're going to have water diffuse in. So then what we see is as water moves into the cell, you notice that the cell expands because it gained water. So think about like a water balloon. As you like hook it up to the sink or the faucet or the hose, you add water, it expands. That's what's happening when a cell is placed into an area that has a high concentration of water. So when it's a high concentration of water on the outside, the water will flow by diffusion or osmosis from a high concentration to the lower concentration that's inside the cell, causing the cell to expand. Sometimes this can be dangerous and your cells can literally pop. Remember, animals don't have cell walls. So our blood cells, if any person is ever given like an IV of like pure water, distilled water, it would actually cause the blood cells to burst because they fill so much. So this happens when there's a high solute concentration on the inside of the cell and a high water concentration on the outside. So when you look at the water concentration outside a cell, that's where it's high, we call this a hypotonic solution. So let's go ahead and look at an example. So let's pretend there's a lot of solutes on the inside of a cell and low solutes on the outside, which would make it a high water concentration on the outside and a lower water concentration on the inside. So now water is going to flow into the cell, causing the cells to expand. Now, we do run the risk of our cells bursting. So this is important. Like, this is why you don't drink like 3 gallons of water in a day, because you would add so much water to the environment around your cells that they can burst and you can die from that. So you don't need gallons and gallons of water a day. Okay, so let's go ahead and summarize, all right, with some words. So here, if we look at a hypertonic cells, a hypertonic solution, the area around the cells is hypertonic. That means that there is a high amount of solutes surrounding the cell and a low amount of water, a low concentration of water. So that means water must be higher inside the cells. So if water is higher inside the cells, that means it's going to diffuse out to where there's lower concentration of water, and that is why the cells shrivel. So water will diffuse from a high concentration inside of the cell to a lower concentration of water on the outside of the cell, which causes them to shrink or to shrivel. Then isotonic was the example we started with. In isotonic, the concentration of water and solutes is equal on both sides of the cell membrane, inside the cell and outside the cell. So that doesn't mean that the water molecules stop moving. It just means that they're moving at equal rates in and out of the cell. So we don't see a change in mass. The cell size stays the same. They are entering and leaving at equal rates. Now, this is ideal. This is what we want our human blood cells and our human cells to be in isotonic conditions. So in our bodies, it's our kidneys that actually work really hard to make sure that we osmoregulate or keep our blood cells and our body cells isotonic. And so that's why if you drink a lot of water, your kidneys will filter it, so you go to the bathroom a lot. If you're dehydrated and you forget to drink water throughout the day, you probably won't go to the bathroom very much because your kidneys are trying to save any water that you do have. Okay, and then we have hypotonic solutions. So in a hypotonic solution, that is where on the outside of the cell, there's a low amount of solutes, but a high concentration of water. And in osmosis, water diffuses from a high concentration to a low. So if on the outside of the cell is the high concentration of water, that means the inside must have a lower concentration. So the water is going to diffuse into the cells, causing them to expand and possibly burst. So water will diffuse from a high concentration on the outside of the cell to a lower concentration inside the cell, causing it to expand or possibly burst, or like swell. Swell is also a good word. All right, guys, so that is my introduction or video on osmosis. Okay, great job.